Chris Mattson here on a beautiful flight on a Cessna, and it's November 26, 2015, in the Okanagan Valley area around Vernon, British Columbia. And a thing to point out here that's so obvious is that no matter where we fly, here you can see the Earth is flat. Sure, there's mountains and valleys and rivers and such, but it's flat. It's a plane. It's definitely not a ball or a globe. Now, I've been in Cessnas flying fairly long distances and such, and you could fly right across Canada here and it's going to be flat. That's just what it is. Now, the ball Earth people will say, well, you know, it's because the Earth is so big. And that doesn't fly. Those are the same people that say you can see a ship go over the edge, you know, on the shore. If that were the case, you know, you wouldn't see this like this. Some of these mountains, the start of them in the distance is 250 kilometers away, like there, and we're seeing way beyond that. You know, we're about between 3,000 and 5,000 feet in this flight, and it's flat.
The gyroscope has the ability to maintain its axis fixed as it moves in 3D space. It maintains the regional horizon line that it was set up at. So if you set it up skew, it would maintain that angle no matter how you move it in 3D space. So the principles that I find in perspective, I find these same principles working in the gyroscope. So this convinces me that the gyroscope, what we are seeing in operation, are the Creator's standards. These same standards we see in perspective, and the Creators put these standards in our eyes. We see according to these standards, where what is upright is always upright. Now in the system, you know, we aren't taught the truth. For a gyroscope to work, the Earth has to be flat and motionless. An aeroplane is flying easterly. Now look how tight this aeroplane turns. Now it turns back and flies westerly. Or the aeroplane's flying westerly, it does a sharp turn, now flies direct easterly. What will happen? You see, they'll tell you, no, you just take a calculator, you add on 500 kilometers, you minus 500 kilometers, you see the airplane travels at the same speed, therefore the Earth is turning. It's simply a load of nonsense. It doesn't add up. For example, if the airplane is spinning backwards with the Earth, right, it takes off, the force is the airplane's being dragged backwards. As that airplane turns now, well, he'll be catapulted forward, and the aeroplane would disintegrate and the pilot would die. So the Earth is not moving, and that's why gyroscopes work. And another reason is that the plane that the gyroscope is on has to be flat. So let's have a look at that in more detail. So an aeroplane, when it takes off, the gyroscope maintains its angle to the ground. The horizon is the same. Say the airplane turns, the gyroscope maintains its rigidity in space. If the airplane takes off or points down towards the ground for landing, the gyroscope maintains its fixed angle to the surface of the ground, and therefore the pilot can turn and land the same angle that it took off from. So some people will say, no, well, the gyroscope, it recalculates the angle. So the gyroscope is pointing towards the Earth and it's calculated like this. Well, that means the higher the airplane flies, the faster it flies. Who calculates that? The gyroscope doesn't know. Well, that means the higher the airplane flies, the faster it flies. Who calculates that? The gyroscope doesn't know. And here's the point. If the airplane turns on its y-axis, for the pilot to realign with the ball, because now the ball's on the left-hand side, the pilot now has to realign its z-axis and rely on its x-axis. So it can't just correct one axis, it has to correct all of them at the exact same time. So if the aeroplane is flying pointing down, if the aeroplane turns right, it has to correct. So the airplane turns to its right, the ball is on its left hand side, the airplane now has to correct its z-axis to realign the horizon. Then the airplane has to swing around and correct itself on its x-axis so that it's always facing the horizon.
So spin angular momentum has the property of stabilizing things. And you will see that addressed in one of your assignments when I want you to address that quantitatively. This is the basic idea behind inertial guidance systems. In inertial guidance systems you have a spinning wheel, at least in the days that the guidance systems had mechanical wheels. But that spinning wheel is mounted in such a way that you cannot put a torque on the axis of rotation of the spinning wheel. That's the way it's mounted. We call it three-axle gimbaled gyros. So the moment that you put a torque on it, the housings, in this case the yellow and the black housing, will start to rotate. And you never manage to get that torque on the spinning wheel. You never get it on this axis. And therefore, if now you put it on your boat or you put it in a plane, a missile for that matter, if you can never put a torque on the spinning wheel, and if the angular momentum for spin is in this direction, it will stay there forever and ever, assuming that we have no frictional losses. And if then the plane turns, the direction of the spin angular momentum will not change. But what will happen, of course, is that this yellow frame will rotate, or this black frame will rotate. And in these bearings here are shaft encoders. And they sense the rotation that the outer housing makes in order to keep this thing pointing in the same direction. And that signal is being fed back to the automatic pilot, and that keeps the plane flying in the direction that you want to. So you use as a reference all the time the spin angular momentum of your gyro, which is now mounted in such a way that you cannot put a torque on it even when the plane changes direction. And I want to show that to you.
So now he's going to spin up the gyroscope, just like the gyros in the artificial horizons of aircraft are spun up, while the aircraft is still on the ground before it takes off from the departure point. And as he said, to ensure that there is a reference point for the departure point, with the axis of rotation of the gyroscope remaining in the same position throughout the flight, no matter which way the aircraft goes, up, down, left, right, sideways, backwards, forwards. The gyroscope will remain pointing in precisely the same direction it was when it was spun up.
Okay, this is the direction of my spin angular momentum. And I'm the airplane. And I'm going to fly. Look at that spin angular momentum. It has no respect for me. It stays in the same direction no matter how I fly. And the error signals that come from the bearings of the yellow housing and the black housing, those arrow signals are fed back to the automatic pilot, and so the plane will stay on course. Now what I can do for you to come to a final test on your thinking, this wheel is suspended in such a way that there is no gravitational torque on it, like there was here. But I can put a torque on it by simply putting some weights on the axis. And what do you think will happen now if I put some weight here on the axis? So the wheel is spinning, but now I'm going to put a torque on it here. It is spinning in this direction. Angular momentum is pointing straight at me, away from you. I'm going to put a torque on like this, putting a weight there, Torque will be in this direction. What will the spin angular momentum do? Torque is in this direction, spin angular momentum is in this direction. Spin angular momentum will start to chase the torque. Watch it. There it goes. The spin angular momentum is chasing the torque. You see exactly the same thing that I've shown you before. And if I make the torque higher, then the precession frequency will go up. See, it stops now immediately when I take it off. Put it back on again. Continues. Put more on it. Goes way faster. What happens now if I put the weight on this side? So I change the direction of the torque. If I put it on this side, torque is now in this direction. Spin angular momentum is in this direction. It's going to reverse direction. There we go. And you see it does. Amazingly non-intuitive. If you have problems with this, you're not alone.
And now, we've all been to air shows and we've seen pilots doing tricks, right? How they flip the plane around in 3D space. And I'll tell you that the pilot maintains his position with the ground through the use of his gyroscope. So the gyroscope, as his position changes, it has to be flat. It has to be level with a flat, level surface. So if the plane takes off, the gyroscope is maintaining the pilot's position that he took off from. The horizon is always flat and level. No matter which axis the pilot spins on, his X, his Y, his Z, and he's moving in 3D space at the same time at a phenomenal speed. He always comes back and he's relying on his gyroscope, that the horizon is true. All he worries about is the horizon. It tells you that the Earth is flat. The pilot doesn't have to rearrange all three axes on the gyroscope. It tells you it's flat. It's as simple as that.
Now, the reality is that the controllers, the Illuminati, global elite, whatever you want to call them, they've lied to us. And, the reality is the Earth is flat. It's just one more thing that is reality. So as we do our research, this is what we find. The observable evidence is exactly what you're seeing. The Earth, in fact, is flat.